Okay, so y'all, since we're dealing with polynomials that have higher degrees, things are going to start repeating. When things start repeating, they start acting really weird on the x-axis. So, first of all, if they do not repeat, you're going to have an x-intercept that we call linear. It's going to look like this. Let's say I factored something and I got just a single x minus 1. Now remember, we don't really write the exponent. It's understood to be a 1. If I have a factor like that, it is going to have straight through behavior. You have to write the letter S. You have to make sure that your S does not look like a 5. And that stands for straight through from one side to the other. Like me walking straight through the door. I'm inside the classroom. I'm going straight through to the other side, to the outside of the classroom. That's this behavior. The second one, sometimes we'll get factors that repeat to an even power. 2, 4, 6, 8, whatever. Anything that's even is a bounce. It bounces off the point and goes right back to where it came from. This is above the point. It bounces off the point and goes right back up where it was. You have to put the letter T if you want full credit for your graphs. And then again, y'all, if we start getting repeats but like it's odd, you're going to have a swirl happening, a change in concavity. You have to write the letter C, especially on these, because it's kind of hard to draw a swirl on these little baby graphs. Okay, here we go. Let's start practicing this. So for number 2, we're going to go ahead and find the end behavior, the number of zeros, everything we did on the front. Then we're just going to graph it. All right, here we go. What's the end behavior? Yes, yes. How many zeros? Yes. How many turns? Good. So now we're really going to see the turns. Like that really did not make any sense to me on the first page, but back here it will make sense. Y-intercept. It is. Let's factor to find the x-intercepts. So what can I take out of this? An x squared? That's going to leave x squared minus 4. Can we keep going? Yes. Don't forget to recopy your GCS on the next line. All right, everybody look at me, and then I'll stop and give you time to get caught up. Your answer, when I ask you to solve this algebraically, x equals 0 for this, but we have to state the multiplicity. Algebraically, the multiplicity is always in parentheses. So when you see your key, look, I'm going to write a positive 2, and I'm going to write a negative 2. All right, you can write that down. So like when you're working through this and you're checking your answers online, if you see any numbers in parentheses, then it's going to stand for a multiplicity. You have to show your multiplicities starting right now. At 10:18, you have to write your multiplicities for full credit. Okay, let's start actually plotting this stuff. So we're going to go ahead and plot these x-intercepts. I know that it goes through the origin. It has a multiplicity of 2. I have to write a t if I want full credit. You have to write the multiplicity behavior on the graph. Let's go ahead and plot a positive 2. Y'all don't put a little positive 2 right here. Use the space of the graph. Spread it out. Let's say 2's right there. And it's straight through. Same with your negative 2. Space it out over there on the left side. It's got an S also. Draw an S. And then listen. The first thing you do is the end behavior. Remember, the end behavior is up. Draw 2 up arrows up here. Then you fill in the gaps. Always draw your arrows first. Minimize getting tripped up. Y'all, not next week, but the week after, we're going to start solving stuff that has this behavior, but they're fractions, which is crazy. You want to get your stuff right, you draw your end behavior first. Okay, filling in the gaps. All right, well, it crosses the x-axis right there, so obviously I have to draw down. Guys, I'm not drawing over my letters. I'm just going to try to keep my graphs as neat as I can. Look, there's a turn, by the way. I'm turning up, and I'm bouncing off that tangent. When I bounce, that's another turn. Here's my last turn right here. I'm doing it as we speak, turning up and connecting to my other up arrow. That's it. That's how you graph them. Letter B. Oh my goodness sakes. What's the first thing you see on B? A negative. Y'all, please remind yourself you're going to have to factor that out when we factor later. But first, let's just go ahead and start identifying the attributes. Yes? Factor out negative. That's a G.
I just can't kind of see what's coming.
Oh, I'm so sorry. How about now?
Yep.
Okay, hold on. There we go. Okay. Okay, factor out the negative when we factor, but let's just look at the attributes. End behavior is so important for you to recognize. What is the end behavior? Down, down. Very, very good. All right, zeros. How many zeros? Yes, there's 2. How many turns? Just 1. Y'all, what's the y-intercept? Yes, 0, negative 16. All right, let's find the x-intercepts. We're going to have to factor to do that. All right, y'all. To factor, the first thing you got to do is get rid of that negative. So let's change the signs. That's going to be a positive x squared minus a 10x plus a 16. And can you factor that? Yes, 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 you can, y'all. So I just recopied my negative. Ooh, I almost made a mess. Just trying to make that a little clearer for us. Okay, guys, what goes in the parentheses? X minus, what is it? 8 and 2, great job. Now look, I want to point something out to you. I factored out a negative 1. I did not factor out an x. So that negative that we factored out, if it does not have a letter to it, it has no value for us in solving. I don't care about that. If there's no x, there's no value to it. So the only x's that we have are positive 8 and 2. So there's my algebraic answers. I'm not writing any multiplicity because those were just regular factors with an exponent of 1. Let's go ahead and start plotting this stuff now. Okay, so I know it goes through the 8, which I'm going to put over here on the right as far as I can. Remember, it's straight through behavior because it just had an exponent of 1. And then it goes through the 2 also, guys. I guess I'll just say 2 is right around here. And remember, it was also straight through. And then where's your y-intercept? It's pretty far below the origin. I'll say it's like right here. All right, I've plotted my dots. Now I'm ready to plot my graph. What do you plot first? End behavior. Great job. So remember, it's down, down. Fill in the gaps. It's going to cross your y-intercept. Go up, go straight through. Change direction one time, go straight through, down to the other side, down to your other down arrow. That's it.